Good morning, everybody. Once again, my name is Vishnu Dutt. I have Dhaval and Prashant with me, and we are into the session number third of our CCNA learning, right? And I was thinking about it that I haven't shared the syllabus of CCNA till now, right? But believe me, that is not going to make sense if I share the syllabus with you right now. Let's have this theory session, today's theory session, and I will make sure that in next session, whenever we are meeting, I will be guiding you what we are going to learn, right? In complete 10 days or approximately 35 to 36 hours. So today's session is going to be again mostly based on theory. And from tomorrow, we will be starting some of the practical stuffs, right? Dhaval, Rohit, or Punish will be helping me with that, right? But today's session is going to be very, very interesting and important. If you get that, then most of your problems when you are going to give this exam or when you are in front of the customer are going to be resolved because we are going to introduce routers today, right? You can also call them routers. We are going to introduce switch today, and we will be seeing that how these two networking devices work. This is going to be very, very interesting, right? So generally, we talk about connecting all the computers of the world. The first thing should be that can you understand if you communicate, if you can you understand the process how two computers which are pretty nearby going to communicate with each other, right? We are going to see the nitty-gritties in today's session, right? Till now, we have just understood what is the meaning of TCP/IP model, how actually your packet flows, and even that too, we didn't discuss about one of the one layer, which is your data link layer, which we are going to discuss today, right? Because I think you must have heard somewhere from someone that routers are layer 3 device and switches work at layer 2 or the data link layer, right? We are going to introduce all these things. So here is the agenda. Here is the agenda of today's session. And this is my promise that if you give me your 2 to 3 hours, the next 2 to 3 hours, I'll make sure that you understand routers and switch, right? And these two devices are going to be most important if you are seeing your career in networking field. So the agenda is we are going to introduce routers. I will show you how these routers actually look like, right? Then we are going to talk about how routers are going to be connected. What do we use to connect these routers? Because at the end of the day, routers are taking our packets from one place to other place. So there must be something which is taking these packets, right? And these are going to be your cables and interfaces. We are going to include the concept of interfaces, cables, and their respective speed, right? It could be possible that when we reach here, you might be lost. So that is why we are here. Me, Dhaval, Prashant are here, right? We are not going to let you lost, right? And then we are going to introduce the concept of data link layer. I was deliberately not explaining the concept of data link layer, and I know that there are many people who have this question in their mind that at data link layer we find another addressing scheme which is MAC addressing, right? Why do we use MAC address if we already have IP address? This is the question we are going to explain today, right? This is the why. For example, if you are using MAC address, there must be some particular reason. Otherwise, the developers or the development of TCP, developers of TCP/IP, or who have created this model, every developer is kind of a frugal. They do not write a code unless it is required. So MAC address switches are required, data link layer is required. That is why we have this layer implemented in TCP/IP model. There is a pretty uh, there is a there is an answer for that, but the answer lies in history. If Even basically, if you ask today from somebody who is having experience of maybe 10, 15 years also, means if you had asked me this question maybe 2 or 2.5 years back, I could have given you the standard answer that basically the IP address are logical, MAC address are physical, that's why we need it. It doesn't mean that if something is physical and something is logical, you need to use both of them, right? We are going actually into the history to find the answer, and you will be amazed to see there is not much technical reason behind it that why do we need a MAC address. There are some something which with respect to ease, right? And that is what we are going to see, that why do we need MAC addresses at the layer 2 if we already have the IP addresses at layer 3, right? We are literally going to see how two computers, packet by packet, step by step, how these two computers are going to talk with each other. Because if you cannot understand the process of how two computers are talking, which are pretty nearby, then forget about that you can learn connecting computers of all the world, or you can understand the reasoning behind them, or you can understand the logic, how every computer of this world is connected. So let's take a small step. We are going to talk about how two computers which are pretty close by are going to communicate with each other. And we are introducing some more rules, some more protocols in it, right? This is going to be one of the most crucial point, the point agenda number or the point number 10, right? If you get that, I would say 50% of this complete thing you will get to know on a higher level, right? And at last, if time permits, we are actually going to see today the real packet. I will showcase you. This is in a tool which is called Wireshark. So basically, if two devices are sending some packets over this wire, what you can do, you can capture those packets and you can learn from them. I will showcase you, right? How to do that also. So this is going to be the whole soul agenda. The point is, you should give me your 2 to 3 hours with full attention, full concentration. If you can give me that, I promise you, next 2 to 3 hours are going to be very, very fruitful from your career perspective. Having said that, let's talk about routers. So we have introduced yesterday about the routers. Now let's see how they work, right? We all know for the fact that routers were able to understand the IP address which we are writing on the packets, right? So as you know that suppose I have Anjali here, right? Maybe Anjali is in Delhi, and we have Rahul here, and Rahul is in Bangalore. I'm just repeating some of the things from tomorrow, but I am introducing some more things today, right? So again, we haven't reached to data link layer. We are talking about the network layer, right? So Anjali is saying, hi, how are you? To Rahul, she is opening a WhatsApp application, and our WhatsApp application has generated the data, and uh, TCP layer has introduced its own header so that it can say that this data is for the WhatsApp application. It is as simple as that, right? So here is the data which is created by uh, transport layer, right? I do not know what is there, but this is my data, right? And you all know for the fact that if this data needs to go via these routers, it should have the IP addressing, right? And we learned about IP addressing yesterday. So this is the network number 5, 192.168.5.0/24. We all know that if it is /24, there are going to be 256 hosts in this. And of course, two IP addresses were reserved. The first IP address, which is 0, which is reserved for this number, and the last IP address, which is 255. This is the IP broadcast address for this network. If you send an IP packet to this address, it is going to be received on all the hosts in this network. Right now, there is only one host, and suppose this host address is 192.168.5.10, say, right? And here we have a network number 7 here again /24. It means that 256 hosts are going to be there. 2 are reserved, and that is why we have only 254. And out of 254, this host, the Rahul's laptop, is going to have this IP address, which is 192.168.7.10, suppose. And now these two guys wants to talk to each other. And first thing first, Anjali should know the IP address of Mr. Rahul or any server which is connecting on the internet. Maybe she could have talked to the Google server, which is 8.8.8.8.8. Maybe she wants to talk to Google DNS server, right? So she should have this IP address. How to get that IP address, it is a totally different thing. But this data, if this data of this application needs to go to this host, there needs to be an IP header. And what this IP header is going to contain, this is going to contain the IP addresses, right? As we all know that if we are sending the envelope, there are two things written on that. The address where it should go, and basically you also write your own address. Why? Because if this letter is not delivered, it should reach to you, or if anybody want to see that from where this letter has come, you can see the sender's address, right? So that is why we have two IP addresses here. Although this IP packet or the IP header is going to have more fields, which you might understand when we when you finish the CCNA session and when you want to do some more things like quality of service or something, right? There are more fields, but the most important field which we are worry about is the source IP address and destination IP address, and that is what I'm going to write here. This is my source address. This is my destination address. You all know for the fact that the source address is going to be 192.168. What? 5.10, and the destination IP address is going to be where this packet wants to go. This packet wants to go to the destination address, which is your 7.10, right? I'm not writing the initial two octet, which is 192 and 168. And believe me, guys, I do not want to write this complete packet again and again. What I'll do is you understand that if this is the IP packet, it is going to contain the data which is coming from the transport layer. We all know about it, right? So from now on, I won't be writing this data. You understand that if this is the IP packet, it contains data. I will show you this thing in the Wireshark 2. So from now on, whenever I write a packet, I will be writing only the source IP and the destination IP. And suppose this IP packet reaches here, right? This IP packet reaches here, and we have the source IP address here, source address, and we have the destination address here. How it reaches from this host to the router, it is a different thing which we are going to talk about in the data link layer. But yes, suppose we were successfully able to send this packet from this host, which is Anjali's laptop, towards the router, right? Or maybe there is a statement that if Anjali wants to talk to somebody who is not in its network, she should send it towards the router, which is nearest to her. And that is the same thing. Where this communication is happening, this communication is happening between two different network. Why? Because one network, which is one network is 192.168.5.10. This is the network, or if I write the exact network, 5.0/24. In this network, Anjali is sitting, right, with her laptop, and Rahul is sitting in this network 192.168.7.0/24, right? She is having the IP address .10, and he is also having the IP address .10. Remaining 3 bits, three octets, you can presume what are those, right? It means that I can easily say that here the communication is between two different network, or here the communication is happening between the host of two different network. And suppose the rules say that if you want to communicate between two different networks, then you should see which is your nearby router. And Anjali is seeing that the nearby router is R1, and that is why She's sending the packet to R1. There is a lot more. How she's going to send this packet, right? There is little bit more information about that too, but we are not including that for now. We are keeping it pretty simple. We want to understand the working of router. Source address is going to be, you all know, again, it is going to be 192.168.5.10. The destination IP address is going to be 192.168.7.10. These two addresses should not change. Why? Because at the end of the day, you want to talk to Rahul, which is having a particular specific IP address, which is 192.168.7.10. It is as simple as that. So this router will receive this packet from where? From this host. Host is Anjali's laptop, and routers does is its magic, right? Suppose routers build this table. How router build this table, I do not know. Maybe this is the point of discussion when we are going to learn the dynamic routing protocols or the static routing. But till now, we are understanding only the pretty high level view of everything, right? But if you understand the high level view, then you can go inside. Otherwise, it is going to be a problem. So suppose R1 has built this table, which is known as the route table or routing table. And this is my routing table for R1. How he has built it, I'm not sure about it, right? And you are also not sure about it. We will be learning it also, do not worry. But let's see what is written here. It is written that 192.168.6.0, this subnet, which is actually this one, it is saying it is directly connected to me. And of course, this is directly connected over this interface, right? Or this cable, whatever the cable is. There is another network which is 192.168.5.0. Sorry for the typo mistake here. Network is directly connected to me. Of course, 5.0 is this network. It is also directly connected to this router over this cable. We are going to learn about this cable too. Do not worry, from the next board onward. We are going to learn about these cables. How you are going to connect these routers using these cables and the ports. Do not worry about it. But for now, just concentrate on this router, and the router has built this table. I do not know how, but he has built this table, and it is saying, the table says that network number 5.0 and network number 6.0 is directly connected to me. It is as simple as that. But it also says that the network 192.168.7.0/24 is a network which is available via R2. It means that R1 is saying, see, 6.0, 5.0 is connected directly to me. There is no doubt about it. But the network number 7.0 is not directly connected to me. But if you want to go to 7.0, I can guide you. You can go via R2. Right? It is not the question of going you and me. It is a question of sending the IP packet. So router 1, when receives this IP packet, right, the green color packet, it is going to check where this envelope or where this packet wants to go, and it sees that this packet wants to go to 192.168.7.10, and it calculates where this 7.10, basically it's going to be one IP address where this lies in my routing table. And of course, 192.168.7.10 is not part of the first route, whatever I have written here, first statement, because first statement says that 192.168.6.0/24 means from dot 1 or from dot 0 to dot 255 is available to me, right? Which is directly connected. Of course, this host 192.168.7.10, it's not part of this statement too. Why? Because this is for network number 192.168.5.0, and I'm not talking about it. I want to send the message to 192.168.7.10. And of course, 7.10 is not here, 7.10 is not here, but yes, 7.10 is here. Why? On the third statement. Why? Because third statement say the network number, which is 192.168.7.0/24, it means that it composed of 256 hosts from where to where? From dot 01 to dot 255, right? 192.168 7.0 to 192.168 7.255, and of course 192.168 7.10 is part of this range. So this router knows that I have a matching route or matching network. I know that if somebody wants to go to 192.168.7.10, I have an entry in my table that I just need to forward it towards R2. It is as simple as that. So what this router is going to do, this router is going to place this packet over this cable and it is going to reach to R2 here. Interesting, right? Now this packet reaches here. This packet reaches at R2 with the same source and same destination, which is going to be 192.168.5.10. This is going to be my source IP address, and the destination IP address will be same 192.168.7.10, right? Believe me, this also happen in case of your postal service. Whatever you have written over this envelope, it is not going to be changed, the source address and the destination address, right? Because this is the logical address. If you change this, it is going to be problem, right? The packet won't be delivered. But yes, who is taking this packet can be changed, right? Because the person who was taking out the packet from the post box will be different. The person who will actually delivering the packet towards the destination is going to be different. That is going to be a postman, and maybe this is guy who was collecting the letters from the post bag. So the guy who take these messages will could be different, but at the end of the day, the addresses are going to be same. It is as simple as that, right? The packet reaches at R2. R2 is going to check its routing table, and R2 is going to see first where this packet wants to go. Which packet? This IP packet, the destination is actually 7.10. It is going to match its routing table, and it will find that 192.168.7.0/24 network, which says again that 192.168.7.0/24, of course 256 host part of this network, and clearly 192.168.7.10 is part of this network, and that is why you are seeing that this network is actually directly connected to R2, and R2 can straight away forward this packet towards this host, and that is how your packet is going to be reaching to Mr. Rahul. It is as simple as that. Now it doesn't matter how many routers you have in middle and how much far away Mr. Rahul is. If these intermediate routers are having routes, they are going to forward it. So the most important piece is that how these routers are going to build this table, right? We will be learning about it. Do not worry. If you have heard about the name of routing protocols, right? Like OSPF, like BGP, their whole sole duty is to build this routing table. If you are thinking loudly, right? Then of course you must be thinking that how R1 is going to learn about route which is connected to R2, or the network which is connected to R2. Maybe R2 is advertising this network, right, towards R1. How this advertisement works, this is all together comes with the learning of routing protocols, which we will be doing. We will be learning OSPF in this course on a pretty high level basis. But the whole sole point is how R1 knows about the network number 7.0. There must be, means these routers are talking to each other, right? And if they are talking to each other, then they must understand the language of each other. And that language is just nothing but some rules. And we call those rules as protocols, right? We all know about it, right? We have seen everything, such thing in the postal service also. For everything there is a documentation, right? And we read the documentation, we do the work. Those documentations is actually the rules, and those rules are known as the protocols, right? So if R1 and R2 are abiding those rules, then it means that they can talk, And if they can talk, R2 can definitely inform, hey, Mr. R1, I have a route which is directly connected to me, which is 192.168.7.10. It is as simple as that, right? And maybe R1 is also informing R2 that I have a route which is 5.10 and 6 or 5.0 and 6.0. Interesting. But I'm not talking about this routing protocol. I'm just talking about that how a particular packet is going to be delivered to the destination if every intermediate router having that particular route, right? So here, what is the role of this router if you can think about it? The role of the router is to connect multiple network. We are seeing multiple networks here, right? Network number 5.0, network number 7.0. I'm not taking the full name of this network because you understand, right? I should have said 192.168.7.0/24 network is there, 5.0 network is there, 6.0 network is there, and these routers are connecting these networks, right? And basically, they are taking the packet, sending it towards other routers so that this packet reaches to the destination one hop or hop by hop. We call these routers as hop also, right? The packet reaches here, the first hop, the packet reaches here, the second hop, and then eventually it will be delivered to this host. So, routing table or the route table of this router contains the network information through which they know that how to reach them, right? It is as simple as that. If you have any doubt with respect to introduction of routers, you are please do ask. Maybe you can ask in question and answer session, or maybe you can ask directly by raising your hand. I would want a hands up, right? Hand raise if you get this board. If if you do not get the board, then please let me know. So I would definitely ask for a hand raise here. And I can see that there are many hand raises, but not everybody is raising the hand. So guys, if you are not raising the hand, then basically I will come to you and ask what is the problem. Okay. So for example, if I see here Vishnu Parajit has not raised the hand. Vishnu, did you get this concept? Or Srishti or Sparsh? Unmute yourself, guys, right? Raghav, Preksha, this is interesting. So there could be only two possibilities that either you get it or not get it. If you don't get it, please do ask what you didn't get. But if you get it, that's perfectly fine. I can see many people here who haven't raised the hand. Maybe one possibility is that you do not know how to raise the hand. So ask your friend that in WebEx how to raise the hand, right? Otherwise, it is not good that I could see that Kanak is there, Mahim is here, Praneeth is here, Preksha is here, right? But you don't raise your hand that you get it or not. So guys, these are going to be crucial things because there is a assignment which is pretty soon delivered by Mr. Prashant to you. Do not depend on the recording because there is a ton of videos available on YouTube, right? Nobody is going to watch them. But yes, some people watch because somebody asked yesterday also that can I get the recording? So just concentrate here. These are very, very simple thing. But if you leave them for tomorrow, you are definitely, you can learn later also, definitely, right? But the problem is it is going to take your more time. If you're sitting here, just concentrate here. Having said that, you can lower your hand. That is perfectly fine. And let's move to the next board where we are going to talk about how does a router looks like, right? So I was able to get this picture from Cisco's website, and this is one of the 8300 series router which we have, which we use in our SD-WAN solution. What is SD-WAN? Doesn't matter, do not worry, right? But this is a router, and if this is a router, it should work like whatever we just discussed, right? It should have the routing table, and inside this routing table, we should see some networks. And this router is going to explain that if you want to reach, if a particular IP packet wants to reach to somewhere, how exactly it can reach, right? And you can see that those routers which I was drawing, right? These routers actually can connect to other routers, and I was showcasing you that they can be connected over the cables, but where you are going to insert those cables, and that is why we have some openings here in routers, right? You can see right here, this is one of the opening, this is one of the opening, right? And this structure is looking like this, the opening structure, right? Like this. And actually, this is your a particular port where you insert the cable, right? And this port is known as RJ45 port. I'm not saying every router is going to have those RJ45 ports, but actually this is the standard, right? It means that to connect into this RJ45 port, you need a cable which can fit into this port, right? And we call those cable as RJ45 cable, right? This is my RJ45 jack. Those are my cables. This you can say the socket also, where you are going to insert the cables, right? So if I want to connect this router with another router, okay, the router symbol is actually this one, which so this, suppose this is router number R1, this is router number R2, and if I want to connect it, so what I need to do, I need to take a cable, I need to insert this cable at this opening, and then the other end of the cable should go here, and then these routers are connected to each other. And if they are connected to each other, then they can send traffic over it, right? Maybe this router R1 is going to get some packet, I'm not sure from where, packet number 1, packet number 2. Then what is it is going to do? It is going to check the IP address on this packet number 2. It is going to match the routing table where it is exactly matching. And if it wants to go to R2, then basically it is going to be forwarded it here. It is as simple as that. It might be the case that over the other router protocol port, this one, there is a complete network connected, right? This network. And suppose this network is 192.168.7.0 or maybe 8.0, say, and the packet number 1 is for, say, 192.168.8.10, and some host is right here in this network. If that is the case, the packet is going to be reaching here. Router is going to check its routing table, and of course, routing table says that 192.168.8.0/24 right here is connected to this port, directly connected, right? And if it is directly connected, then the packet, this yellow packet, should go over this wire. It is as simple as that, and it will be reaching here, right? So do not worry about it. You will see plenty of routers in your career. Okay, so this is the hardware piece, and I just wanted to showcase you how does it look. Yes, but there are some more ports too. Like we have this USB port if you want to send some data inside this router, and you are going to see some other ports also, which doesn't look like a RJ45. Do not worry, we will be talking about it. These are the SFP ports. But the opening, whatever you are seeing here, these are your ports. These ports are going to have some interesting numbers, right? So suppose we are having here 4 ports, you can see here, right? All of the ports are Ethernet port. I will showcase you. Let me clean the board first. So you can see there are 4 ports, this one, this one, this one, and this one, right? And if I say, suppose take an example that if I tell Aman Kumar Singh that Mr. Aman, you have a cable here, the green color cable, connect it to the Ethernet port. So basically, sorry, connect to the RJ45 port. I should not tell the name which we haven't discussed. Ethernet, which we are going to discuss pretty soon. So RJ45, right? I am giving you a cable and I am asking Mr. Raman, can you connect it to the RJ45 port? Then you are saying, absolutely, I can do that. And you take this cable, you reach to this router, and there you get confused that Mr. Vishnu, you didn't tell me where should I connect. I can see 4 ports are available here, right? I can see 4 RJ45. This cable can go into these 4, right? Any of them. Where should I connect? Then if I say, suppose I am on the phone, if I say on the left hand side or the right hand side, it is going to be problem. So what we do, we name these ports, right? And the naming is in some specific manner. So suppose for this guy, I am calling this as my 0/1 port. Interesting. You must be thinking, why such name, right? You could have easily said 1. Why 0/1? There is a specific reasoning behind it, but I do not want to discuss it now. So this port is 0/2. Suppose this port is 0/3. This one is 0/4. If that is the case, I could have easily told Mr. Raman that Mr. Raman, you need to connect this port, this cable, whatever I'm giving to you, to 0/1. It is as simple as that, right? So if you go and check, it is definitely written there that this is the 0/1 port of this router, or this is the 0/2 port of this router, and that is why we name these ports. So I think from this diagram, you should understand that there must be the requirement of some cables, there must be requirement of some sockets, right? So that you can insert these cables into the socket if you want to connect 2 different routers with each other. You need to take a cable out from particular socket and insert into another one with the help of this cable. We are going to talk about what are the different types of sockets you are going to see here, right? One I have showcased you, that is the RJ45, right? The other one I have shown you, this is the cable, and this is basically RJ45 cable, which can go into the RJ45 ports. The name might confuse you. What is this RJ45? But this is the name of these cables. Okay, the naam mein kya rakha hai? That is perfectly fine, right? Having said that, and please explain logic behind 0/1. Sanya, I will be definitely, but not now. And there is a specific reason. I do not want to make confuse because whatever I am explaining you right now, this is the router is in its most basic form. There are some other things also in the router. If I include that, that is going to be too much for you, right? Having said that, I can see there is a question from Rachit Puri also. Is USB port in the router used to connect it to a system which can configure the router? Uh, Most of the times, this USB port is actually to uh, which can configure the router. Yes, you are right. Means there is a console port also in this router, and there is a USB 2. And I'm not sure with the recent routers what is happening, right? But yes, previously there used to be a console port. We connect that console port to our laptop or router, sorry, our laptop or PC. Then we can configure this device. What is the meaning of configuration? We will let you know, right? But yes, I have seen that through USB cables also it is possible to configure this device. That's a good question, right? By the way, Dhaval, can you see the questions from these guys?
Yeah, Vishnu, I was just answering Rachit's query.
Perfect, perfect, perfect.
Yeah.
Right? Sanya, do not worry about it. It's a good question which you are asking, but actually it is making people more confused about it, right? So do not worry. We will be taking it during this course itself. Okay? Just hold the horses. Having said that, let's move to the next board here. So where are we right now? Okay. So I can see there are some hand raised from Khushi, Praneeth. So do you guys have some questions or doubt? Or basically these are the hand raised from, okay. I think Divya, you have question? Divya Josh? No. Perfect. So where are we? As I discussed, this is the important document which will keep you track that where are we with respect to current learning. The learning is going to be based on all these layers because at the end of the day, what we want to do, we want to make sure that computers talk because this is the problem we are trying to solve from first session, right? We are into the third session now. And TCP/IP model has broken this problem into 5 layers, and we just learned about network layer, but not fully. But whatever we should know for this point, till this point, we know about it. In network layer, we could understand IP, what is IP address, right? We also understand the logic behind IP address. We now also understand if there is a big network, how to divide this network into multiple pieces. And interestingly, yesterday I asked a question and nobody responded on the WebEx chat the answer for that. Guys, I am expecting an answer. Please do write. If you have any doubt, you can ask here too. The question was that if we have a route, if we have a subnet, which is 192.160 or the network 0.0/16, can you divide it into 2 parts and then can you divide it into 4 parts? If that is the case, then what is the broadcast number and what is the subnet number, right? Please try to do that in your free time because if you do that, then it is going to be very, very easy um, uh, understanding the upcoming session. So we have understood in the network layer what is IP address, what is the logic behind IP address, how you are going to subnet a particular big network, right? Then we also talked about routers and how routers forward packets, right? Forwarding means sending a packet from one place to another place, right? If we have router number 1, if we have router number 2, let's send a packet from R1 towards R2, right? It is as simple as that. So we have introduced routers now. We have introduced that how these routers are going to be connected to each other. Now this is a right time to look into the physical layer. Why physical layer? Because we want to send data from R1 to R2. It is going to be, it will be over these cables or whatever the ports we have just discussed. So let's talk about some of the things in physical layer. And I am again deliberately leaving data link layer because once we discuss these ports, once we discuss these cables, I will definitely come to the data link layer, and the next 2 hours or 1.5 hours is going to be in data link layer only. It is as simple as that. And interestingly, somebody has posted the answer in the chat. That's Romil Jain. Perfect. This is great. I will see the answer, right? But it is the expectations from everybody. Just try to solve this, that if you want to divide this network into 2 pieces, how you are going to divide this, right? Thank you so much, Mr. Uh, Mr. Romil. I'm not sure. Romil Jain, sorry, right? Romil Jain, thank you so much for giving the answer. And now let's talk about the physical layer. If you see the physical layer, we are talking about the cables and the connectors, right? Maybe this portion is a little bit boring for you, but believe me, this is again important because if you are, say, if you are carrying your CCI lab or if you are into the data center of the customer, right? Sometime it's not always that you need to connect these cables or you need to work with these connectors and something, right? But the real network engineer is who should understand, right? Maybe somebody can ask you that can you help me in connecting these 2 routers? Which cable I should use, right? So the whole sole point is most of the times we see the network engineer this drawing that there are 2 routers, R1 and R2, connected over this cable, nothing else. This is just a logical diagram, right? Or you can say this is the physical diagram, but this is not giving you any clue about what this router is. How does it look? or basically what are the interfaces on these routers. And sometimes because we do not know all the routers, all the modules on this router and nothing, right? So we do not know how many cables are there, but we can definitely go inside this routers, run some commands to check what are the capabilities of this router, how many ports this router has, and what are those ports, what actually the standard of these ports, right? So if you see that I have drawn the same thing here, that we are having two routers. This is the pictorial version that how two routers are connected over the cable. And this is the actual thing which you are going to see in your data centers or maybe in the actual lab. So we have two routers, router number R1, router number R2. You know about it. We have their ports, this port and this port, right? This is connected over this green cable. This port is known as RJ45 port, right? If you enlarge it and see, you are going to see this, right? Most of you must be wondering that do I need to take care of all? Do I need to understand this? Believe me, everybody, yes, you should, because there are many people who will be depending on you, right? I have seen in my career that if I have if we are building, uh, I think I'm getting the echo back. That is okay. Now it's fine. So what is happening here is that if I am building a complete network for the customer, most of the time, suppose this is the United States, right? And I'm sitting here, most of the time we are on the WebEx call, and the guys who are actually putting these cables, those are the vendors, right? Sometimes they ask questions that where should I fit this cable? Then you must be asking, can you just send me the photograph of the router? And we all do that because we sometimes we work remote, sometimes we are on site, but most of the time we are on the off site, right? We are working on the if we are working on the WebEx or any meeting, right? Then we must be guiding them. Okay, this cable should go here. Although we need to give them the complete Excel file, so that they can create this topology where every port should be connected. But sometimes you never know, this vendor doesn't know about the cabling, right? If they do not know, you should know because this is very, very simple, right? So behind these routers, you are going to get RJ45. And I was amazed to see few years back that I was seeing a router and there was no RJ45 port, and I got confused what to do that because I was not good with the with these hardware things, right? So these are the actual cables which, and I will give you the example that where I don't see any RJ45 port, then which cables I'm going to use, right? So these are my RJ45 or Cat5K cables, right? The green color cable. It is not always green, but these are, right? And of course, on this wire, whatever the green color wire you are seeing here, we have the copper wire inside this, right? And there are 8 wires. I will showcasing you, do not worry. And those are 8 wires, and we are seeing 8 pins here. And these 8 pins should go exactly here, right? So this complete end should go inside this. This is your socket. If you insert it properly, then basically we say that the connection is done at one end. And that is why I have showcased you this with a green cable, which is connected to two RJ45 ports on the router. It means that now these two routers are connected physically and they can send traffic. What traffic they are going to send, this is your responsibility to log in into this router and to write some command so that it can behave whatever you say, right? It can obey your command. Whatever you say that this packet should go here or here, right? You can configure a router like this, which we see in the configuration section. What is the meaning of configuration? The meaning of configuration is just simple. You are accessing this device just like you access your PC. It is going to give you the console. What is the meaning of console? The console is something on which you can write down your commands, right? Suppose you want to say that this route, the packet toward this route should go to R2 and you are writing it in R1, right? Then you should write that instruction in this console, and then router is going to take this instructions, right? And it is going to behave whatever you said. It means that you are giving some instructions to the router from this console, and router is obeying those instructions. It is as simple as that, right? So this is just the pictures so that you have something in your mind that if a router, of course, if a router comes, if you're drawing a router on a board, then you should draw like this. This is the symbol of the router. But yes, physically the router looks like this. I'm not saying that every router is going to be the physical router. There are some virtual routers too. What is the meaning of virtual router? Do not worry, we will be covering somewhere in this course, right? But right now, as I mentioned, this is absolutely the very what we can say high level view of the router, how router looks, how you are going to connect it. But these are the most fundamental things too. Okay, having said that, let's move to the next board where we are going to talk about interfaces, right? So on the left hand side, if you see this router, this is perfectly fine. We have seen this router just now. It is having these ports, and we all know that these are the RJ45 ports. These are the RJ45 socket. This you can see here. So what I see, we see four RJ45 ports here. But this is something where my RJ45 cable is not going to go, right? And that is why we need standard. If somebody is saying that my router is capable of taking a RJ45 cable, then it means that it has implemented a RJ45 socket, right? That means that cable can go inside this. It is as simple as that. But suppose if this guy is not having this, and I have this RJ45 cable, then I afraid that I won't be able to connect it because this guy doesn't have RJ45, and that is why we need standards, right? What is the meaning of standard? This guy says my router is fully capable of doing RJ45. It means that it is having those ports, right? You cannot connect an RJ45 cable in a USB. It is as simple as that. Just try. You cannot, right? So this is my interfaces, and the name of the interface suppose is 0/1, right? Naming you all know. Now, interestingly, few years back, I saw this kind of a router too, and then I was looking around to see how I can put my RJ45 cable, right? Or the CAT cable. We also know these cables at CAT 5K cable, which I was showcasing you as the green color in the previous board, right? If I try to, because this doesn't look like a RJ45 connector, and to my, so that was because my knowledge was really less at that point of time with respect to computer hardware, right? It still is, but now the pictures are easily available, and what was happening, I can tell you the story, right? Somebody was on the phone and he was asking that we want to connect the routers at the customer premises, right? And according to your diagram, whatever you're saying, and you are saying that this router is R3 and three cables should go out from it to other, right? And I have these RJ45 cable. But the interesting thing is I cannot put this cable into this because I do not see an RJ45 port here. And I was on the other side of the call, right? And I was literally saying it is not possible. It can't be possible, right? Then he said that I can straight away send you the photograph, and he sent this photograph, and I was amazed to see. Then I did some Googling that yes, there is a change, right? So instead of making this port a RJ45 port, these people are generalizing it, right? Because you never know that whether you want to connect two routers, router number R1, router number R2, with a RJ45 cable or the copper cable, you do not know about it, right? Or maybe you want to connect these R1 and R2 with another type of cable, which is your optical fiber cable, right? On copper, you can send electric signals. On optical fiber cable, you can send light. At the end of the day, the whole sole purpose is to send this 1010. You can encode these 1010 in the form of electric current, or you can encode these 1010 in the form of light. If you are sending this 1010 in the form of light, then basically you want to use the optical cable, right? And then these guys were thinking that we can do, and this model you can see that there are four RJ45, but one port is something which is general, right? You can fix an Ethernet port, and you can also put an optical cable. Sorry, Ethernet cable, or sorry, the RJ45 cable or the optical cable. Then you must be thinking this guy is mad. He just said that we cannot put anything here with respect to RJ45 because this doesn't look like RJ45, right? So here is a solution for it. They say that we will be delivering you the device like this. You will be responsible for making these ports maybe an optical fiber port or RJ45 port. It is as simple as that. Interesting, right? So they have developed these universal sockets, right? These pluggables which can go, and you can see that basically the front side is looking like RJ45, right? And the back side can go directly into this. And if I put this into this socket will become the RJ45 port. If I put this socket, this will become the optical cable. So by the way, guys, this is my optical ports, this one. And I will showcase you the optical cable too. So if I want to make this particular port as the optical, I will be introducing this guy. If I want to make this particular port as RJ45, I will be inserting RJ45 pluggable into it. And these are known as SFPs, right? And the full form is small form factor pluggable. If you do not like the full form, that is why we have the short form also, SFPs. Call them SFP. The right hand side SFP is for the optical cable, and the left hand side SFP is for the copper cable. It is as simple as that. So basically, this is to ease our life, not to make it difficult, right? But yes, if you do not have any SFPs, you cannot connect any cable on the router, which you see right here, right? So this is all about ports. And by the way, guys, as I was mentioning most of the time, Ethernet cables, right? So there is a standard. So whatever I'm saying, the RJ45 or RJ45 port or RJ545 cable, this is developed by, right, by the people who were trying to connect computers together. And you must be thinking this is what TCP/IP model was also trying to do, right? Absolutely, you are right. But at the same time, there were some people who wants to connect, and they were discussing what should be the cabling, what should be the port look like, right? And they give this cabling and standard name as the Ethernet name, right? I'm not saying Ethernet only deals with the cables and the port. Ethernet has some cool concept, and which we are going to talk about, and that is why these Ethernet concept is going to come to layer 2. So at layer 1, Ethernet also defines some of the characteristics of the cables as well as the ports. And that is why sometime you must be hearing that I'm calling this cable as the Ethernet cable and this port as the Ethernet port, right? So RJ45 is developed by these Ethernet guys, and the name is the Ethernet standard. That is why you can call it the Ethernet port or Ethernet cable also. If you're talking about RJ45 port, you can say it is the Ethernet port, right? Or if you're giving this cable, the green color cable, you're fitting inside the RJ45, you can call it the Ethernet cable also. It is as simple as that, right? Any doubt, any question, please do ask. Dhaval, do we have any doubt?
Yeah, there was one query from Sanya,
Mhm.
but I guess she got her answer.
Perfect, perfect. Okay, so I am presuming that everybody is getting, right? Because this is just the hardware thing. I think nothing much. But now let's talk about some more cool stuff. How much data I can send per second over these cables, right? We need to understand that too. So if we talk about the left-hand side, we are talking about RJ45. We are talking about RJ45 plug, right? Or the socket, which is also known as Ethernet, right? These are the Ethernet cables or the RJ45 cables. So believe me, you find these uh, plugs or the sockets in four forms. Number one is if a port which can take Mbp 10 Mbps of the traffic. What is the meaning? The meaning is 10 million bits per second can go inside to this port and can go outside, can go out of this port, right? This port is capable of doing that. So if you connect a cable which can carry 10 Mbps, then basically this port is also capable of sending data, right? And if I want to clear some of the doubts, then 1 bit, is the smallest unit. If you combine 8 bits together, it is going to make 1 byte, right? If you combined 1000 bytes together, then it is going to make 1 megabyte, right? But we are not talking about megabyte. This B is small here, right? It means that this is representing single bits. So million means 10 to the power 6 bits per second can flow, right? So there is one standard which we call 10 Mbps, which is also known as the Ethernet standard. Then 100 Mbps cable you can see, which can take care of the 100 Mbps data speed. This is known as fast Ethernet. Then one interface that can take 1 Gbps. Again, guys, this B is not capable. This is bits, not capital, right? We call it 1 gig Ethernet, and there is another one which is 100 Gbps. Sorry for this. Although we have 10 Gbps, which can take, which we call which we also call 10 gig Ethernet, right? So if you see Ethernet, fast Ethernet, 10 gig Ethernet, you should understand what is the meaning of it, right? So these are the cable which comes, these are the ports which come into this category, right? A port can be either 10 Mbps, 100 Mbps, 1 Gbps, 10 Gbps, and many more also, right? Because nowadays we can see 40 gigabits per second and even more than that, right? Interesting. So these are our Ethernet standard also. But the problem with Ethernet standard is that the cable length can be only 100 meters, not more than that. It means that try to think what I'm saying here, that if you want to connect two routers with these cables, right, these routers should not be far away than 100 meters. Interesting. 100 meters is just nothing, right? So if we depend on this Ethernet, then basically we are just creating a network which is pretty small network. But yes, you can say that uh, Basically, if have so many routers, then 100 meter, then we can take this to 1 kilometer, right? By putting so many routers, but it is including so many routers here, right? Can't we have something which can take my packets to distances, right? And that is why we have a new technology or the different technology, not the new one, which is the optical fibers, right? So if you see this router on the right hand side, we see that the general port, and if you insert this guy, which is the SFP, which is the optical SFP into this, then basically we can see that this guy can send messages to the longer distances because now we are using the optical cables, right? So there are two little ports inside one port. One is to receive data, one is to transmit data. And it is written here that what this if this is transmit, it should go into the transmit section. If this is receive, this should go to the receive section. What is the transmitting means? If you want to send data, you are transmitting the data. If you're receiving data, you are receiving on this receive port, right? So this is how your optical fiber cable looks, right? Which should go into this SFP. This SFP should go into this generalized port. It is as simple as that. But now the distance is significantly improved. These optical cables can take data to 30 kilometers. We are talking about only 100 meters here, guys. And now it is actually 30 kilometers, which is huge distance, right? Interesting. But this cable comes into two flavors, multi-mode and single mode, right? And I'm going too much deeper, which I should not. Multi-mode. Actually, if you talk about single mode and multi-mode, this is all related to the principle which we have read, the total internal reflection of light, right? If you do not know about it, that is perfectly fine. But we must have heard about it when we were reading the 10th, 12th grade physics, right? The light can go very fast to the distances, right? But here the multimode fiber can take till 500 meters. Still, I'm saying 500 meters, but yes, the single mode fiber can be used for the longer distances. Why? Actually, this is just outside the scope of this because we are talking too much hardware now, right? But interesting, if you see that there is a need for connecting two devices which are pretty far away, then we should be using the optical cable instead of using the Ethernet. And the reason is the Ethernet is only to connect devices which are pretty near to each or Ethernet or basically these copper cables, right? Interesting. Having said that, let's talk about other board. So we will be finishing this hardware thing, and when we come back after the break of half an hour, we will be talking about the data link layer. And you should all be here to understand this because that is one of the most important piece of this complete syllabus of your complete career also, right? So let's talk about it. Let's see right inside this cable, and mostly I'm going to talk about the Ethernet cable, right? As I mentioned that if you open this green wire, you are going to see these many cables, right? And you can see this is not the cable, this is the pair. This, by the way, guys, this is not the cable. You are seeing the one pair number one, pair number two, pair number three, and pair number four. Four pairs which are twisted together, right? And that is why we call them the twisted pair also, or the UTP cables also, unshielded twisted pair, because these are not shielded by any material, means any strong material. We have only the plastic covering. But yeah, why twisted pair? Because these two guys have been twisting. And what is the reason why do we twist these cables? I leave it for you. Just Google it, right? And maybe you can post the answer on the group too, that why we twist this. Means maybe if somebody is from the electrical background that can tell me. But now I want to talk about these 8 wires, right? And this is going to be very, very interesting discussions, guys. So just put some more minutes before going to the break, that why I am so curious about explaining these concepts to you, because these are important, right? So we have these 8 cables here, right? These are the cables, which may be the green or white one, which you can see right here. So 4 pairs means eight cables. And believe me, we use 1 and 2 for transmitting. If you want to send some data to the remote end, and that data is going to be the electric over the electric current, but at the end of the day, it is 1010, right? It is going to be TX, which is we send data on 1 and 2, and we receive data on 3 and 6. You must be wondering, what? Where this 4 and 5 gone? This is what it is, right? I do not know why behind it. Maybe you can look it, right? Why they haven't chosen 3, 4. So basically, we are receiving on 3rd and 6th, and we are sending on 1 and 2. And basically, this is done by your PCs. If you connect your PC to this Ethernet cable, and if your PC wants to send data, it is going to be over 1 and 2 wires. And if you want to receive data, basically it is going to be over 3 and 6. Because if you are sending on a particular wire and somebody is sending in reverse direction, there could be a collision, right? You do not want that. That is why you are using the separate cables for sending the data and receiving the data. It is as simple as that. So as I mentioned, that if this is the PC, right? If it is sending on 1, 2 and receiving on 3, 6, what is going to happen if you want to connect two PCs? Let's see. There is going to be disaster. Nobody is going to send, nobody is going to receive. Why? I will let you know. Because the yellow line shows sending of the data, 3 and 6 shows receiving of the data. Let's see what is going to happen if we connect. And this is a specific type of cable which is known as a straight through cable. What is the meaning of straight through cable? The meaning is 1 and 2 are sending, right? And 3 and 6 are receiving. But there is another cable type 2, which is the crossover cable, which I will let you know. What is that? But let's understand first the problem. Suppose this is my straight through cable, because at the end, what you are going to do, you are combining all these uh, cables, right? You are going to make them twisted pair. You are going to give them to me in this form, and I will be connecting two PCs. Here are my two PCs, and I am connecting them together with this cable, which is known as straight through cable, right? This one, straight through cable, right? This end is going here in the PC, this end is going here in the PC, and of course, PC should have this RJ45 connector. You must be wondering that I haven't connected any time the cable into my PC. That is fine because we are using the wireless. But yes, at the end of the day, every data is going over the wire. You must be thinking that right now we are in Cisco campus. I do not see any wire. I don't connect a wire into my laptop to access the internet. Yes, you are right. Because the technology is now advanced, we do not need this cable to connect me to the nearest switch, right? That is a wireless. That is perfectly fine. But let's connect these two PCs over this wire first. Wireless, we can see later. The principles are going to be exactly same. But yes, you have connected this PC through this straight through wire. And now suppose this PC belongs to Anjali and this one belongs to Rahul, and they are happily connecting these two with the straight through cable. Now Anjali wants to send some data 1010, and she's sending the data over these two because these two can transmit. Perfect, right? And here is my problem, because this is the straight through cable. One end is connected to 1, 2 is connected to 2, and basically for Rahul also, this is for transmission. 1 and 2 for Rahul is not for the receiving, because this is the straight through cable, right? And we are talking about computer, we are talking about laptop. And if that is the case, then basically, and if we are connecting them through the cable, which is the straight through cable basically transmit data on the 1 and 2, and Rahul also transmitting data on 1 and 2. It means that Rahul is not receiving these data on port number in 3 and 6, which is its receiving port, right? And that is where the problem is. Anjali is saying that my TCP/IP model is working fine. Rahul is saying my TCP/IP model is working fine. I am sending the data towards Rahul, but nobody is receiving the data, right? Interesting. Why? Because we are sending on 1 and 2, and Rahul is also sending on 1 and 2. The data is that the data never come on the receiving end of the Rahul, and that is why this is the problem. So we came across the solution. The solution is going to be pretty simple. If you want to connect two computers, then there must be rearrangement of this wire, right? This wire, if I showcase you, that this whoever is sending from this transmit side, right? One end of the transmit side should be connected to the third, right? So if I'm transmitting here, the wire is actually connecting at the third port there, right? Or the third pin there. So basically these are the wires, right? We call them the pin also, right? So here I am transmitting, and then basically it is received at the third, right? So I have cross connect this wire. Similarly here also, from second, basically I'm going to send it to the sixth one. So 1 and 2 I am transmitting, and 3 and 6 I am receiving. It is as simple as that. Here also, if I go other way around, then 1, whatever I'm sending from here, it is going into the third of Miss Anjali, and the second is going into the sixth of Miss Anjali. It is as simple as that. So you have rearranged the wire so that you can match transmit and receiving things, right? And now the communication is perfect. But now this cable, the new cable which you just formed, is actually your crossover cable. It is as simple as that. But you all know, whether it's a straight through cable or crossover cable, at the same time you can transmit and you can receive the data. And if at the same time you can transmit and receive the data, the communication is known as the full duplex. Why? Because the communication is happening in each direction at the same time. At the same time, Anjali can forward the packet towards Rahul. Rahul can send the same the different packets on the different pair, right? And that is why the communication is full duplex, because we are using two different pair of pins or the wire for the sending and receiving the data. It is as simple as that. And by the way, guys, we use these standard for 10 Mbps and 100 Mbps. So we are talking about fast Ethernet and the Ethernet. But there are some new advancement which we are talking 1 gigabits per second interfaces, 10 gigabits per second interfaces, 40 gigabits per second interfaces. You must be thinking why we are not using remaining four wires or remaining two pairs, and that is what these guys are doing, right? Because they need higher speed, and that is why they are utilizing all 8 wires or all 4 pairs. It is as simple as that. So guys, if you want to connect two computers together, computers send on 1 and 2, receive on 3 and 6, you should connect it through the crossover cable, not with the straight through. If you are using a router, believe me, router is also doing the same thing. It is sending on 1, 2, receiving on 3, 6. But we are going to introduce another concept, which is going to be a switch. Pretty soon today, switch actually does the reverse. It sends data on 3, 6 and receive on 1, 2. So, right? If you do not get it, that is fine. This is my router. Router and PCs behave the same way. They send data on 1, 2, receive data on 3, 6. And if you want to connect them, you should use the crossover cable, right? Otherwise, there is a problem. But if you want to connect a PC with a switch, which we are going to introduce now, basically PC is sending data on 1, 2, and switch is receiving data on 3, 6, right? Switch is, sorry, switch is receiving data on 1, 2, and PC is sending data, receiving data on 3, 6, and switch is sending data on 3, 6. So basically, you need a straight through cable here. Crossover won't work. And then you must be thinking, Mr. Vishnu, you have made us confused. I'm summarizing it once again. Till now, we have talked about 2 things or 3 things here. We are talking about the PCs, right? We are talking about the routers, R1, R2. I'm just saying that if this PC wants to send data to another PC over the cable, it sends the data over 1, 2 and receives the data over 3, 6. And if this guy is doing the same thing, you can see the difference. You are sending on 1, 2. This is sending on 1, 2. There is a collision, right? That should be like this, and that is why you are going to use crossover cable. Similarly, in case of R1, 1, 2, 3, 6, 1, 2 to transmit, 3, 6 to receive, and that is why you are going to need this guy. If you are connecting a PC to router, again same thing, router send the data on 1, 2, receive on 3, 6, PC send the data on 1, 2, receive the data on 3, 6, crossover, right? But I have introduced one thing which is different than this, and the different is the switch, which we haven't introduced it, right? Switch actually send data over 3, 6 and receive over 1, 2. Interesting, right? Or if I say it sends data, so basically PC sends data on 1, 2, so this guy receives on 1, 2, and this guy sends here, transmit here. So if I want to connect a PC with the switch, right? I need a straight through cable. Why? Because I am sending data on 1, 2, which is automatically receiving on 1, 2. So I do not need a straight through cable. It is as simple as that, right? But now you must be thinking too much of things, too much of physical things. So I will remove this problem, right? I would like to tell you today's routers and switches and PCs are so intelligent that you do not need to care about whether you should use straight through cable or the crossover cable. Why? Because there is a feature which is known as auto MDIX, right? Which actually, so if you are connecting 2 routers, right, router number 1 and router number 2, and suppose you have connected them to the straight through cable, generally it should not work. But now the routers are intelligent enough to see that they are connecting, that somebody is sending on the 1, 2 port, so they just change the receiving and sending port, right? It happens automatically. Then you must be thinking, then why, Mr. Vishnu, you have wasted our time? Because I want you to understand that maybe sometime you need to work with the old model of the switch, which does not support MDX feature. If that is the case, you should know that you are using the right cable. But you do not need to worry in the latest, or means I'm saying latest, then I'm talking about 4, 5, 6, 7 years, because I don't face any problem, such problems, right? I just connect the wires. Switches are important, intelligent enough to, or switches or routers are intelligent enough to switch on the basis of whatever is required. Interesting, right? So this is the whole soul thing with respect to cables and everything I wanted to talk about. Straight through and crossover we have just covered, and perfect. We are good with respect to these ports and the hardware. If you have any doubt or any question, please let us know. And that is why I have written there, right? Are we lost? Right? So what we have covered till now, I'm just again repeating, we have covered network layer, mainly the IP addressing part of it, subnetting part of it, and how router is going to forward the packet, right? But this is not all about network layer. Network layer has so many things also, but we do not need to cover everything. We just need to cover OSPF routing protocol also, and we will be done with the network layer, right? We just talk about some form of physical layers in which we are talking about the crossover cables, the optical cables, how they are going to connect. We all know about it, right? Now, if we if you ask me where are we with respect to the complete picture, we are right here. We have just covered network layer, we have just covered physical layer, and I am going to talk about more now data link layer. The remaining portion of this session is going to be because we have learned so much thing about the cables and the connectors and the ports. Now, and as I promised, you are not lost. We just talked about the physical layer, we just talked about the network layer yesterday and today, and now this is the time to data link layer. I was deliberately not discussing this data link layer because it could have create some confusion, right? Uh, Everybody, please be on mute. Sai, Lasya, please be on mute. Just wait a minute. So I was deliberately, it was quite deliberated that data link layer was not discussed till yet. Is not discussed till yet. And now, uh, let's see what is there at the data link layer. So here is the first board. So we are starting the data link layer now. And first thing first, we want to understand why behind data link layer, right? So I have divided this board into two different boards. Number one is left hand side, and here is we have right hand side. So if we talk about left hand side, we have just discussed when we were discussing network layer, we were actually discussing this. What was the concern of network layer? The network layer concern was that how this guy, which is sitting in network number one, can able to communicate to somebody who is sitting here, right, in network number four. This network could be in India, this network could be in maybe US, and so on. So basically, network layer was dealing with how to route packet or forward packet between networks, right? Doesn't matter, these networks are where. So maybe there are so many networks which is built by so many people, and network layer responsibility is to connect these different network. And most of the things was done by these routers because these routers are somewhere in the middle which are connecting these different networks. Because on routers you all see what was connected. On routers, networks were connected, and the job of the router was to forward the packet on the basis of IP address. We have discussed about in yesterday's session, in today's session. We have discussed about these cables also. So whatever we have discussed this board, how to route packet or how to forward packet between these networks. So I am deliberately introducing some words here, right? So if I talk about till now, we have introduced router. We know what is RJ45. If I say how to forward the packet, you should understand the meaning of it because packet is going on the hop by hop basis, router by router, right? If I'm saying that how to route the packet, the thing is same that the packet is coming on the router, and because router is seeing its routing table to know where do I need to send this packet, and that is why I'm saying you need to route this packet. So if my words are making sense to you, this is good thing. If they are not, just ask the question. It is as simple as that, right? So it might be the case that I speak some word because I have been into this industry for so long, and that word might not make sense to you, right? Just ask that. though I am doing a cautious effort to not using some terminology unless I defined it. Having said that, this is what we have discussed till now, routing packets between the networks, and that is where our network layer was responsible for. We talked about these cables, these sockets, and now let's talk about what do we see inside a particular network as we see that this is the network, right? If we talk about network number 3, let's say the network number 3 consists of 3 hosts, and we all know that these 3 hosts are part of the same network, right? Now we are not talking, if I talk about how Mr. A, who is sitting inside this network A, wants to talk to Mr. B, who is also sitting inside this network, can network layer resolve this problem too? Because network layer whole sole responsibility was to send packet between these network. Can I put a router here and say route packet here, route packet here, route packet here too? Do we actually need a router here, or can we do this thing with something else? And believe me, in during 1970 to 1990, right? And that is why I said that if you want to understand data link layer, you need to go into the history. Otherwise, you are not going to get the answer, right? And I have seen on the internet that people have asked this question that why do we need data link layer or the MAC address if we already have IP address or network layer, right? And the people were scolding others that you even do not know this. This is the basics, but they are not giving answers to it, right? Because answer lies in the history. So 1970s and 1990s, if I talk about, people were making TCP/IP model, right? And around 1990, first version was up and running. People were able to send the messages across between two computers which are far away also, right? So TCP/IP model was doing magic. But don't you think that during this time there were some other people also who could have done this thing in different way, right? So if I talk about and during 1973, and you all know that the TCP/IP discussion was going on, development was going on between 1970s to 1990, and this was done by maybe say 100, 200 people. I'm not sure about it, but yes, there was a parallel discussion going on that how to connect, how to connect different hosts which are pretty nearby. Interesting, right? Because, see, inventors, developers, and basically the curious people are always there. There are some group of people, right? There is a group of people maybe who was not aware with the TCP/IP. They were building their own network, but they were concerned about that how to send the packet between two devices if they are pretty close by each other, right? So suppose what is happening here, whatever I have drawn this cloud like structure, suppose this is a room, a big room, right? And I have 4 people inside it. Here is the Anjali, here is the Rahul, maybe here is somebody number C, here is somebody, the name is D, suppose, right? And now Anjali wants to send some packet to some information to Rahul. They are in the same room, the big room, right? They are sitting across the table, and there are many people also there, right? And Anjali want to convey some information to Mr. Rahul, right? And she is saying, "Hey Rahul, how are you? Do you think that this message should be only going to Mr. Rahul?" No, because if she speaks and she speaks loudly, then this message is going to go to Mr. C also, to Mr. D also. So I'm talking about now the what is going on into the mind of other people who were trying to solve the same problem, but on a lower level because they do not know that TCP/IP is going to come. The development was going on, but they do not want to wait for it. They were introducing their own model. They were trying to work on something which is they were trying to send messages to people who are pretty close by to each other, right? And I would tell you that why this approach is not going to work if we talk about the computers of all the world, right? So Anjali is saying, "Hey Rahul, how are you?" This message should go to Rahul as well as C and D, but who is going to respond? Of course, Rahul is the name of this guy, and that is why he is only going to respond that Anjali, I am doing great. Do you think that C and D is also respond? Nobody can stop them to respond, right? But I'm saying that this is whatever the people are sitting here are the civilized people, right? And there is no prank going on. So only Mr. Rahul is going to reply, Anjali, I'm fine. It is as simple as that, right? But this approach can work if you are pretty close by. Suppose now this room, which you are seeing here, let me increase the board. Suppose this room is in Delhi, say, where these four people sitting, right? And there is another room now, which is not in Delhi, and this room is in maybe quite far away, maybe in Bangalore, say. And again, there are 4 or 5 people sitting here. You must be thinking what this device is with these arrows. This is not circle, this is the rectangle. I will talk about it. Do not worry. We will introducing this device to you. But first try to understand what is going on in this people mind, right? So there were 4 more people here. Maybe now Rahul is not here. Rahul has moved to Bangalore. Here is Mr. Rahul. And then we have X, Y, Z, maybe Q here, and Mr. Rahul is right here, right? Connected means sitting across a table. This, for now, just consider this device is a table, right? We will introduce it later, that this device is going to be the switch, right? Pretty simple. Now, do you think that this approach is going to work? Then you must be asking, which approach, Mr. Vishnu? The approach was simple. Anjali is saying, hey Rahul, how are you? But Rahul is not here. Interesting. Anjali is broadcasting her message to everybody. And suppose there are so many rooms, such rooms in the world. Do you think that Anjali should go to every room and shout here? Hey Rahul, how are you? If somebody is there, Rahul is there, then he's going to respond. This approach is not going to good, not going to be good. Suppose this message, whatever Anjali is saying, hi, how are you, which is a broadcast message, is taken by somebody, maybe that router, although router does not carry the broadcast message. But try to think, if somebody can take this message also, then you must be thinking this router is going to ask here, who is Rahul, right? Or hi Rahul, how are you? Do you think that this message should go in every room of the world, every network of the world? No, right? So, although these people were solving out the problem, which is quite okay, when we are in a single room, we can say, we can broadcast to everybody, hi, Mr. Rahul, and Mr. Rahul is going to respond if Rahul is there. But this approach is not going to work if we have so many networks in the world, so many such rooms in the world. So, by the way, guys, if we are talking about close proximity, if we are talking about that these computers are pretty nearby, we are talking about local area network. Why? Because this is the network and this is part of your local area, right? So, if somebody is in Bangalore, he has created its own network where 4 or 5 people sitting, Rahul is there also. This is their local area network. Maybe in Rajasthan, maybe in Odisha, right? Maybe in Hyderabad too. You have so many local area networks here. And these people were able to solve the problem that how these people are going to talk inside this particular local area network. But when there is a question that how a particular guy in a particular local area network how it going to be connect to any other local area network, then these guys have no idea about it, right? They were saying that whatever we are building, this is only for a local area network, right? And whatever the standard these guys were developing, these standards were known as Ethernet. Interesting. At the same time, some people were discussing a problem that how to send a packet to maybe 500 kilometers from R1 towards R2. These people were discussing the problem of wide area networking, right? Because now we are talking about 500 kilometers, which is a huge distance, right? So you should be agree with me uh, that different people, different approaches they are taking to build this network. But yes, at the end, TCP/IP model was winning, right? By a margin because they have the pretty higher view. They know TCP/IP know how to connect the network of entire world, which we discussed, right? Using the routers. Ethernet knows only that how to connect computers inside the same LAN. And believe me, these networks based on Ethernet were increasing, right? Suppose if I take an example of Delhi, maybe suppose if every university in Delhi or every hospital in Delhi was aware of this Ethernet technology. So every hospital one is going to build its own local area network. Maybe 50 people are here, and if 50 people that go talk together, they can share their data. It is good, right? Another hospital can also build their LAN too, and they can run the Ethernet, right? But what if this hospital one wants to connect to hospital two? Ethernet technology was based on broadcast. Anjali was shouting, "Hey Rahul, how are you?" If Rahul is here, he's going to respond, otherwise not, right? You cannot say the same thing in going every hospital. This was the problem. And that is why we have the TCP/IP model for. TCP/IP model has solved this problem, how to interconnect any network. Doesn't matter which technology, on which technology it is working. But TCP/IP model was able to connect this different network, right? And that is exactly where TCP/IP model was saying that I am going to have one application layer, then basically below that transport layer, which is used to check whether the destination is there to synchronize the packet with it. And then basically we have the network layer, which is actually solving the problem of interconnectivity between these networks. It is as simple as that, right? And then TCP/IP says, I do not care. I am responsible for sending packets between network. I do not care what you are using inside that particular network. It is going to be your responsibility to send this packet across. If you are using Ethernet, use Ethernet standards. If you are using any other technology like point to point, which is basically talking about sending packets between two devices, and now there are only going to be two devices because we are talking about point to point, means there are only two devices at the end of this cable. Sorry, this cable has only two devices, one at one end, the other at the second end, right? We call them such topology as point to point. So network, just try to understand what I'm saying. The TCP/IP developers were saying, I do not care what do you have below it. I can send the packet, whatever this application is sending between networks. Doesn't matter if this network is in Delhi and the destination network is in USA. I do not care about it. It is my responsibility to forward it. But inside a particular local area network, whatever you are running, it doesn't matter. Use that thing, right? And in LAN, we were running Ethernet, which is based on the broadcast technology. Broadcast means same. Anjali shouting, right? So network layer, what it's going to do, whatever it is receiving from the transport layer, which is the data, it is going to put its own header, which contains the IP header, and then it gives this complete information to data link layer that it is now your responsibility. Whatever technology you are running, just do it, right? And you must be thinking that what are those different technology? I have heard about Ethernet. See, Ethernet is mostly you are going to see everywhere, but it doesn't mean that there was only Ethernet technology at the LAN layer, at the LAN side. There were other technologies too. But yes, Ethernet was the one which was taking attention of many universities, many people, and that is why we were able to see many networks based on Ethernet. And now TCP/IP is saying that do not worry about it. I do not care whether what is running inside a particular LAN, right? You use that. My responsibility is to take the packet between the network layers. So basically, they have defined a data link layer in which there could be anything which you are going to use in the local network. Maybe this is Ethernet, point to point, frame relay, or whatever, right? Whatever is running here doesn't matter. If you do not get it, that is perfectly fine. But the whole sole point was, if you go into the history, around 1973, people were building another network which is solving problem of their LAN, means local area network. It is based on the broadcast technology. Why they were building? Maybe they did not know that TCP/IP is in the formation, right? But TCP/IP model has a larger view and it can include the Ethernet also, and that is why after the network layer they have introduced another layer which is data link layer, because they are saying doesn't matter to me whatever you want to use. I will be giving you the IP packet. It is your responsibility to forward it in your local area network. And now I would like to tell you how these Ethernet guys actually were able to send the packet. So basically they have this switch, right? And switch has many ports, okay? And on these ports, they have connected different PCs, which are pretty nearby, by the way, right? This PC is A, this PC is B, this PC is C, this PC is D, and maybe E here, right? Just try to understand this. And I'm talking about the local area network. Of course, if this is a PC, I am now concerned more about how to computers talk when they are nearby, right? And suppose everybody is running Ethernet here. Interesting. But as you know, TCP/IP is also running. So at the end of the day, suppose this is the Anjali's laptop and Anjali wants to talk to Rahul. Rahul is connected somewhere here, right? This is Mr. Rahul network, right? So TCP/IP is implemented here. It means that application is going to generate the data. It is going to reach to transport layer, which is going to put its header. Then IP header is going to be put here, which will say, suppose the IP address of Anjali is 192.168.1.1 or 10/24, and IP address of Rahul is 192.168.1.20/24. Both are part of the same network, right? So this IP packet is going to be generated. This IP packet is now delivered to the Ethernet guys. That I do not care how you are going to deliver it, just deliver it to, because Ethernet is so special that it can deliver any packet, whatever you are going to send to this destination, right? So Ethernet will say that this is the data for me, whatever you are sending here, which is the green colors header, IP header, and the data, whatever you are going to send me, this is just the IP packet for me. And what I will do, I will put my technology on top of it. It is just like the way that the letter is going inside to this envelope. Doesn't matter what you are traversing, what is written in there. Ethernet is taking this IP and just putting it on, and the process is known as encapsulation, by the way, right? And now we have this Ethernet here. Ethernet guys were pretty convinced that if they need to send this, they need an IP, they need an address, right? But they do not know, they do not care about the IP addressing, the Ethernet, because for them it is actually anything, right? Maybe if there is another protocol, for example, at the network layer, whatever we have discussed the IP addressing. Maybe there could be another protocol, right? And if that another protocol traffic I want to send, for me, it is just a traffic, whether it's from the IP or from another protocol, maybe X. I will be getting the packet from the protocol X, but to me, I need to forward it to Mr. Rahul, right? So these guys should be needing another form of addressing, which they call the MAC, because they do not care about, because they didn't know about that the IP addressing were there, or maybe any other protocol was there. Their intention is whatever this machine was generating, whether the IP packet or the packet from any other protocol, they are going to send it on the basis of MAC addresses, right? So suppose the MAC address of this Anjali is M1, Rahul is M2. What they are going to do, they are going to put that this IP packet is from M1, the source MAC address is M1, and the destination MAC address is M2. This packet is going to give it by this switch. We forward this to switch, and interestingly, guys, this switch only understand these MAC addresses, nothing else. If you send a pure IP packet, means where the IP header is there and your data is there, switch is going to just say, uh, I do not understand this packet because I only understand MAC address. So switches were created by this model, or basically this standard, which is known as Ethernet, because switch forward on the basis of because switch forwards on the basis of MAC address, it is going to see that, okay, it is the packet is for M2. M2 is directly connected to me over the maybe 0/4 port, and this is 0/1 port. It is going to forward like this. It is as simple as that. But how switch knows that what is connected where, right? How switch knows that M1 is connected to 0/1, M2 is connected to 0/2. We are going to learn it today. Do not worry about it. But this is the whole soul thing, how Ethernet works. Ethernet works on the basis of MAC addresses, because the guys who were developing it do not know that there is a parallel development going on, and these TCP IP guys knows that, yeah, when they were developing this network, that there are going to be so many networks which are solving this problem, right? Which are solving the problem of how two computers which are nearby going to connect. So TCP IP model vision was great. It's a bigger vision. So basically they say that on the basis of network layer, I will be forwarding packet between these rooms, between these networks. There are going to be so many networks, but inside a particular network, if you want to move, you need to have the MAC addresses, which were developed by these Ethernet guy. It is as simple as that, right? So this is the overall answer for your question. Why do we need MAC addressing if we have already IP addressing? Because they were built parallelly, and TCP IP model at the later point of time included this into the TCP IP, right? Using another layer which is known as data link layer. Data link layer deals with how to forward a packet inside a local network, right? Whether it's based on Ethernet technology or whether based on any other technology, doesn't matter, right? Because if the packet comes to you as an IP packet, how it is going to be delivered, on what medium is it going to, mostly it is going to deliver on the Ethernet. You need to follow the Ethernet rules, and Ethernet is basically based on the MAC. It doesn't understand the IP address, as I mentioned, right? Having said that, let's move to the next board, because over the few boards we are going to repeat whatever we have understood. Why repetition? Because it is good. Repetition is good because it is going to be in your uh, subconscious mind, the concepts, right? So basically, why behind, we are again discussing why behind data link layer. As I mentioned, the example there, right? We have these short networks everywhere. This is the Delhi network, this is the Bangalore network, and this is maybe the US network, right? I'm not sure who is building that. Maybe this is built by some hospital, this is built by in Bangalore some university, and this is built by maybe some enterprise, right? And now they want to connect. Maybe this enterprise wants to connect to Delhi, right? So in 1973, there were development going on, and believe me, Ethernet has won the race. And if somebody is deploying their network in their local area network, they were using Ethernet technology, and now it is de facto method, right? if we make any network, it is based on Ethernet technology, but inside a LAN, because as you can see, uh, we were discussing some of the cables and something for the fast Ethernet. That cable can go only for 100 meters. Although there is some cable that can go 30 kilometers if you are using optical fiber, right? But yes, it is not covering the entire globe. So there are going to be different networks which are based on these Ethernet technologies, right? And having said that, I'm again going to repeat one more thing, that how, let's introduce again in a formal manner what a switch does and what is the MAC address. And suppose here we have the laptop A, Anjali's laptop, which is exactly here also. She's here, we have Anjali, right? Anjali's laptop application layer, of course, it is going to be, and I'm again repeating the complete TCP/IP model, guys, right? Now we are including the data link layer 2. We are not eliminating data link layer, right, from the discussion. So what is going to happen? Application is going to generate 1010 data, which is in the form of stream, is received by the transport layer. Transport layer is saying that this data is for WhatsApp application, right? Whatever the data is it's receiving, right? So it is saying, and let me put one red color header. This is going to be your TCP header, guys, which is saying this is for WhatsApp. And now this complete thing from here to here is my segment, right? When it goes down to the network layer, what network layer is going to do? Network layer will be having this data, then this TCP header, right? It is going to put its own header, and the process, whatever is going on, is encapsulation, right? Let's take that with the, let's write with the green pen. And here we have the network layer. Network layer is going to put IP addresses, right? And suppose at data link layer, as I mentioned, there could be many technologies. It could be the point-to-point, it could be the Ethernet, it could be any other technology, because there are so many layer 2 technologies available, right? But we see most of the time Ethernet because it is pretty popular, right? So if we want to send this packet over the Ethernet, actually over the wire, then we need to use the services of data link layer. And what data link layer does, it is going to take this data, whatever is coming from the application. It is going to take this TCP. It is going to take this network layer header. It is then going to include it into another header, which we call as the layer 2 header. It is as simple as that. What this layer 2 header is going to contain, right? This is going to contain the MAC addresses, source MAC and the destination MAC. Network layer is going to contain source IP and destination IP. For data link layer, it doesn't matter what is inside. It is going to send the packet on the basis of L2 only, or the MAC addresses only. It is as simple as that. So Anjali is going to give, Anjali's laptop is going to give complete IP packet. Complete IP packet to whom? To the Ethernet. And this network, guys, whatever we have built using the switch, is actually your Ethernet network. If you want to send this IP packet over this wire, right, you cannot send IP packet over this wire unless you have Ethernet header on top of it, because, right, if you want, because this interface of your laptop is going to be Ethernet interface. As I mentioned, RJ45. If that is RJ45, that is going to be Ethernet. And if you want to make sure that your IP packet reaches, you need to obey the rules of Ethernet, which says include my header, which is a responsibility of data link layer. It is going to say this is the source MAC and destination MAC. The switch, when receives this packet, it will see what is the destination MAC, and it will be forwarding it towards Rahul. It is as simple as that. Interesting, guys, right? Dhaval, do we have any question? Because this is very, very important, and I expect some questions out of it because, right? Dhaval, do we have any question here?
No, Vishnu, not as of now.
Okay. So, can you please raise your hand, guys, if you get something out of this board? Okay, interesting. There are few hand raises. Okay, one request, please do understand it. I think we met yesterday with some of you folks, right? As I mentioned, these are going to be very important, right? Having said that, let's move.
So, Vishnu, so I think Arya has a question. It's not related to this, but uh, it's when we are going to see these devices in real, means in physical form.
That is
Is
interesting.
that part
Maybe,
of this
yeah,
thing or?
maybe Dhaval, we can take them to the data center in Cisco, right? We can show
Yes.
them. Yeah, it's a pretty interesting thing, right? Arya, thank you so much for giving us some ideas. Definitely, we can take you to Cisco data center or Cisco labs there, which are available on I think, every building, right? And I think, Dhaval, I have the access for some of the labs, right? So
Yeah.
maybe sometimes, yeah, we will be taking you. That's okay.
And also Aditi is asking if you can explain the working of LLC and MAC sublayer of the data link layer.
Logical link control, and that is what we are
Yeah.
discussing. Do not worry. Ethernet is not complete. This is just a big picture. And today, if time permits, I'm not sure because we are already having 35 minutes. If time permits, I will definitely showcase you how this logical link layer is going to work, right? Do not worry about it. Okay. Anybody else?
No, Vishnu.
Okay.
That's all.
So let's finally include this packet. So you all should agree with me that over the Ethernet, the packet flows with this switch because every host needs to connect to this switch, right? We all know for this for sure, right? And this switch understand only the MAC address. So now let's understand this MAC address. Let's see whether it's also logical like IP address or not. If it is not, then how the structure is. And first thing first, where exactly you can find this, right? So here you go. I am formally introducing the MAC addresses now, right? So suppose we have this PC, right? And you all can know that basically this PC can be connected with the cable, and we have this RJ45 cable here also. But if you want to say that where exactly this cable is going to be connected here, this cable will be connected to network interface card. And I'm extremely sorry that I haven't put a network interface card diagram, but you can straight away Google it, that how a particular NIC look. Actually, this is a card which is in your laptop, which is going to give you a port for RJ45, right? But this is a complete card, and there is a port on it where you can fit this cable connection, right? And the interesting property of this NIC is that it comes with an address written on it. And that address is actually the physical address because it is programmed into this device itself, into this network interface card itself. Okay, so this address is actually a 48-bit long address. You must be thinking IP address is only 32-bit. Yes, it is 48-bit long, and you can understand there are going to be 248 combinations, right? So maybe every company has been given some ranges, and on the basis of that, they are producing these NIC cards, NICs, right? Interesting. This 48-bit is a long number, and that's why we are using hexadecimal numbers to write this. Interesting. What is hexadecimal? I think you all know about it. There are some number system which we know. The binary is known by computer. It is based on only two values, zeros and one. Then we all know decimal number system. Decimal number system is pretty straightforward because we are talking in decimal number system from our childhood. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, because there are 9 different characters to denote this decimal, sorry, 10, and that's why we're calling it the decimal, right? And then basically other one is hexadecimal, where we have 16 such values, 0 to 9. And then we are introducing the characters from English language, which is A, B, C, D, E, and F. 6 these and 10 these are making 16. So if you see something written like this, that A colon B colon something ABC, right? Or 0, 1, 2, 3 colon something. If these are making the 48 bits and somebody is saying that it is a MAC address, you should understand that yes, the MAC address can contain letters from A to F also, because it is written in hexadecimal number system. You can Google it, that what exactly, and basically you can find. So the today's exercise is, whatever the laptop you are on, right? Just find the MAC address associated with the Ethernet port of it. How to do that? Just Google it. If you are on the Windows laptop, if you can do ipconfig/all, you are going to get, it is going to give you all the interfaces, and maybe that interface to where exactly, which is the NIC, which where you can connect this cable, right? If you're on the Mac laptop, if you do ifconfig, I think /all, I'm not sure about it, then basically you are going to find the MAC address, right? Written there. Also, you can find the IP address too, but we are discussing MAC addresses, right? So MAC address is actually burnt. It is right there. It is hard coded on this network interface card. So, and believe me, it doesn't have any logical structure. It means that, what does it mean? It means that if you are a room of people having laptops, it could be the case that this guy is from Dell, taking the laptop from Dell, and they are using the NIC card of some company, and this is using NIC card of some other company. And if that is the case, that this range of MAC address is totally different as compared to this range. But if we are talking about the IP address is going to be logical, because we know that if it's the same room, then we are going to give, and this is the part of the same network, then we are going to give, it's a complete network address, which is might be 192.168.10.0/24. It means that all the addresses, all the hosts are going to get addresses from this range, from 256, because we know that there is a /24 mask, right? But the MAC address could have been different, right? Doesn't matter from which range, but yes, every device in this world is going to get the MAC address, which is already hard coded into the network interface card, right? Interesting. But if that is the case, don't you think that there is a problem now? And what is the problem? The problem is, how come this switch knows about what MAC address belong to what, right? Okay, if I remove, okay, sorry for this. I need to explain you the problem once again. Because we all know, if we are talking about Ethernet, we are talking about a particular switch here. And from this switch, which only understand the MAC addresses, and suppose there are some cables connected, and over these cables some PCs are connected. This is PC of Anjali, this is PC of Rahul, and this is maybe PC of somebody else, maybe the PC number C, right? And now here is my problem. The problem is, as I mentioned, this switch forwards the Ethernet, whatever the unit which is coming out. And by the way, guys, just like at transport layer, we have unit which is known as segment. At network layer, the unit was packet. The data link layer, whatever you are receiving the packet, IP packet, data link layer is putting some header over it, and we call this as frame. So if I introduce this term, if I say frame, you should understand I'm talking about layer 2. And in that frame, there is an IP packet. And inside that IP packet, there is a could be the TCP packet or the UDP packet, and then basically the application generated data. Because you all know that after IP, there is going to be the TCP header. After TCP header, there is going to be the data. Exactly, right? But for data link layer, all this is absolutely data. What is there inside? It doesn't care. Now, first thing first, if Anjali wants to send something to Rahul, how are you? And if network layer has generated this IP packet is going to have the IP address of Rahul. There is no doubt about it because this is a complete network. This is going to be the complete logical network, right? Which is having the IP address 192.168.10.0/24. Suppose this is the mask. Suppose Rahul address is .20 and Anjali address is .10. What is the meaning of that? .10 meaning is 192.168.10.10 and here 10.20, right? So IP address IP packet contains all this information, right? But data link layer is going to send this using the MAC addresses. Suppose the MAC address of this Anjali is A:(A:(A) and Rahul is B:(B:(B). Why I'm writing this? Because this is the hexadecimal number, right? I can write this. If that is the case, the source of this address is going to be A:(A:(A) when the packet is generated. But here is my problem. The problem is, how do I come to know the destination MAC address, right? I cannot go to Rahul and say, Mr. Rahul, just give me your network interface card. I want to read the MAC address on top of it, or just tell me that, right? It's a problem because every computer in this world is going to have a net address which is not logical, which is physical, which is the burnt-in address. And if I want to send it here, I do not know about it, right? This is the problem number first of Ethernet network. And that is why Anjali is going to shout that, Mr. Rahul, can you give me your MAC address? Because I want to send an IP packet to you, right? And that is why there is a special address which is known as F:(F:(F), which which every switch understand that if a packet comes with the destination MAC address of 1F:(F:(F), I would like to forward it to everybody. It is as good as broadcasting the message, right? And at layer 2, this is the broadcast address. At layer 3, what is the broadcast address we all discussed about yesterday? But here I'm talking about the layer 3. Here is the IP packet. I do not know what is exactly the MAC address associated with R, and that is why I am writing F:(F:(F) and sending it to here, and switch is sending to every port because I have informed Mr. Switch, I have programmed the switch that if you get a message in L2 header with L2 header which says this message wants to go to F:(F:(F), understand that you need to forward it on every port, and that is what we known as broadcasting of packet, guys, at layer 2. Switch is capable of doing broadcast. What is Switch is going to do? It is going to take this packet, it is going to generate copies of it, and it is going to forward here as well as here. There must be a curious question, right? Does Switch need to forward the packet on the same interface from where it gets? No, because at the first place, the switch gets this packet or the frame over this interface. There is no point of sending it back, right? So apart from the port from where this packet was received, switch is going to forward it to every other port. if the destination MAC address is F colon F colon F, and that is why the packet is reached to Rahul as well as this C, and Rahul can check that actually this is for me. And the reason is why? Because I have that whatever we have written here in the IP packet, right? This host can understand the complete IP packet, right? Because it has the complete layers implemented, right? It can open the IP packet, it can see that this packet is for me. I am going to reply to Rahul that Mr. Rahul, I have B colon B colon B as a destination MAC address. So if now on you want to send me the packet, just write the B colon B colon B, and this switch is going to forward it, right? In the meantime, switch is building a table. How it is going to build the table, do not worry, we will be explaining it. But the problem was broadcasting. The problem was that it is going to be the similar way. Anjali and Rahul and so many people are there in the same room. Anjali is saying, where is Rahul? Rahul, how are you? Right? And Rahul is responding, hi Anjali, I'm here. But this message has been listened by everybody, right? Along with the Rahul, and Rahul can reply. It is as simple as that. So from this board, if you just understand, if you do not understand anything else, if you understand that if we have a frame, right, and in this frame, if the destination MAC address is F colon F colon F, and if this packet reaches to this switch, switch is going to broadcast it. Switch is going to send it to everywhere, right? But not on the port where it received this packet. It is as simple. And the whole sole point is that this broadcast message for something which Anjali wants, that where the Rahul is, and Rahul is going to respond it, right? Although the process is slightly different than this, but if you understand the meaning of broadcast here, that is going to be good. If you understand the meaning of broadcast, let me explain you the meaning of unicast also, right? So if we have a switch here, and if we have a host air A and host air which is B, the MAC address of this is A colon A colon A, which is connected over 0/1 port of switch, and this is 0/2 port of switch, and the B has the MAC address of B colon B colon B. And if A has generated the packet which is having the source address of A colon A colon A and the destination MAC address of B colon B colon B, of course the packet which is inside is going to be IP, because IP is the protocol which we all use. But maybe few days back or few years back, there were some other protocols also, but IP won the race. That is why we are having IP. And this is the source MAC, this is the destination MAC. When it reaches here, if switch has this table which says that if you receive a packet which is B colon B colon B, just forward it to 0/2 port, because B colon B colon B is connected to 0/2 port. And then it doesn't matter that how many ports are there on the switch. Maybe we are going to have 0/3 also, which is C. Maybe we are having 0/4 port also, which is D. If that is the case, then the switch is going to read this table, which is known as CAM table, content address memory, right? If you do not like the word, forget about it. We will be seeing it later too. But right now, if I say this, switch is going to see that we have B colon B colon B, which is connected over 0/2 port. So this packet is going to be forwarded here and it will be reaching here. Now, this packet is not forwarded to anybody else because switch has a table for it, right? And this message is going from A to B. This is one-to-one communication, which is also known as the unicast communication. Previously, if the destination address is F colon F colon F, if the destination address was F colon F colon F, then the switch is going to be forwarded it here, here, as well as here, not on this port, because at the first place, this packet is going to be received over this on this port. It is as simple as that. I hope you are getting this, right? What is the difference of between unicast and broadcast? Broadcast message is going everywhere, and I have informed this switch, I have hard code, I have programmed this switch, I have literally written a code inside this switch that Mr. Switch, because you understand only the MAC address, if a particular MAC address is having a value f colon f colon f, just broadcast it, right? We are the developers. The developers are like us, right? They can do anything. And these are some of the rules. These are the rules of Ethernet, that if somebody comes with f colon f colon f, forward it to everywhere. That is why Ethernet is a protocol. Ethernet is a group of protocol. There are so many uh, standards defined by Ethernet. We will be covering it. Some of the standards are defined in the wireless area too. And because of this broadcast, there is a unique problem if you have heard about the term loops, right? Inside the network, inside the layer 2 network. This happens only because of these broadcasts, right? I will let you know how to deal with that too. But overall, whole sole point of this complete discussion is that you understand the meaning of broadcast address and what is the meaning of unicast communication. Having said that, if you have any doubt, any problem, do ask about this, right? Because now what we are going to do is we are going to start how to compute a stock when they are in the same network. So somebody has asked, can you explain LLC and other things also? We will be covering that right here in this board. But I would say whatever we have covered till yet in these 2.5 hours, this is a lot of information which you get today. I will be releasing the video on YouTube pretty soon. You can watch it there unless you get the access of my website, bridgewire.com, right? And I have also posted all the links till yet, right? Just go through them. If you haven't gone through any of the link, it is going to be pain for you guys in the coming future. If you are not planning to build your future in the networking side, that is perfectly fine. That doesn't matter then you are learning networking or not. But if you have a slightest of chance, right? If you're thinking about networking as a career, doesn't matter into the development or maybe into the design field, these are the things which are going to be with you, right? Having said that, now I am open for question. I'm not covering this, right? Otherwise, you all will be highly overloaded with the concepts. Although I have decided, means when I was starting the session, I was thinking that actually I will be showcasing you how the packet looks, right, over the Wireshark. This is just a screenshot. I will showcase you how the packet looks exactly in the Wireshark, right? We will be seeing that structure that we are seeing the TCP first. Inside the TCP, we are going to see the data. This data is going to be built by the application. Then we are going to see the IP address. At the IP address, we will be seeing the source IP and the destination IP. Then we will be seeing the data link layer one by one, and it will be like this, right? Right now the packet is not, this is basically the R packet. What is the R packet? We will be covering it tomorrow. But do not worry, we will see this packet in actions too. Once you see the packet uh, live, how actually it looks, then I think you will be more comfortable in all these concepts. Having said that, Mr. Dhaval, do we have any question?
No, Vishnu, all the questions are answered now.
Okay. Anybody else wants to ask any other question? Okay, so how many of you says that we should stop now and we should not cover the next topic? Hand raise. I can see only two, three. I'm again repeating the question. Do we need to learn this today? Because I feel you must be highly overloaded till now. Right. Okay. That is perfect. So what we are going to do now is let's talk something else, right? Let's talk something else with respect to Means for next 5 minutes, I will take only 5 to 10 more minutes, right? So as somebody was asking that, can we get a chance to see these devices in real? Do not worry about it. We will be taking you to the Cisco's data center, right? We will be showcasing you routers, switches, firewalls, and so many things, access points, the wireless devices, everything there. Do not worry about it, right? But now, from last 3 days, we have been talking about theory, and believe me, all this information was absolutely necessary before you do the practicals. But first thing first, what is these practicals, right? What do you want us to do, right? This is the question. So there are two ways. There are two ways that we have here 125 people approximately, right? And what I do is I can give you everybody two switches, maybe two routers, so that you can play around with them, right? These are the physical devices. But believe me, Cisco is not going to be ready to give everybody two devices because these devices are really, really costly, right? So this is the one approach which is out of question for sure, right? But there are some ways because we have so many devices available inside Cisco which have been used by many business units, right? And those are there. And if you can request them, those devices can be yours. You can put those devices into the lab and do the cool stuff, right? Configuring these devices. This is again an option, right? But I don't think that I will be able to provide 125 into 4 devices, right? It is not possible. It is almost 500 devices, right? And then the cables too to interconnect them. The second and better approach is to use a simulator. Then you must be thinking that will this simulator going to give me the complete experience just like whatever we had in the physical device? And I would say absolutely yes. So there are multiple simulators available for your CCNA study. Believe me, the packet tracer, which I think Mr. Dhaval has informed you about the packet tracer. This is the software. If you
Yeah, Vishnu.
install,
Yeah.
if you install this software into your laptop, right? That instead of buying those physical devices, instead of getting those devices will be there in the software form. You can drag and drop there, and you can connect them. You can assign IP address to them, and you can start communicating, right? Interesting. And that is what Mr. Dhaval has told you, right? So from where you are going to download the executable for this, you should go to the Cisco Academy, Cisco's Learning Academy, and there,
Yeah, I have shared the URL, Vishnu.
yeah,
So you
yeah,
can go and register there and can.
perfect. So basically that was not recorded. That's why I'm repeating once again so that this is for
No,
the,
that was recorded. I think.
oh, that was recorded. That is great. Then you can share the recording with me, right?
Yeah.
I will be including it
I
somewhere.
think Prashant has it.
Perfect, perfect.
As Prashant was host, so he had web files.
So
So
we have talked about only the packet tracer with them, right?
correct, yeah.
Okay.
What's his application and all,
Yeah,
yeah.
so if you say that, so this is for CCNA level, this is more than sufficient, guys, more than sufficient, right? But I know that there are few people who are going to be very, very interested in learning more and running more switches and routers. Maybe they want to go to learn BGP, they want to learn MPLS or so on, right? Maybe there are some guys, right? And then basically CCNA packet tracer is not for them because this is some limited connectivity, sorry, some limited commands, right? Although whatever commands are required at the CCNA level, absolutely that is there. But if you want to do some higher studies, there are two softwares available. Again, those are actually your simulators. Number one thing is basically we have NetSim available here, network simulator developed by Cisco, right? And what these guys are doing, they are going to give you complete hardware and they are going to install network simulator on top of it. And again, you drag and drop and you start doing your work. This is again a cool, but yes, this is actually running, now if you are doing this over the physical hardware, it is actually running your router. So there are no commands which are not there. Whatever you want to learn on a physical router, you can run over the netsim, right? netsim.cisco.com if you are interested. There are some outside vendors also which they have developed, and those are pretty cool software, right? Some of them is developed which were outside is GNS, and the other one is Eve NG. Again, you can download these software, and basically these software are running your actual Cisco hardware images, Cisco's routers and switches, which you can also download from Cisco, right? Install them. There are ample of documentation, ample of videos available. So basically, the whole world is open for you. I would say Packet Tracer and NetSim is the way to go. One of the coolest software, right? But if you want to explore more, you are always welcome to have a look at GNS and even G. And believe me, guys, these software are going to give you the functionalities. For example, if you have three routers connected like this, right? R1, R2, and R3. And if R1 is sending something to R2, you can definitely go here on this wire and capture this packet. And this packet will be showcasing in a pretty neat manner, right? Means it will be showcasing the TCP header, IP header, the data itself, and the data link header too. I will be showcasing you tomorrow, right? And that is how I did. I just captured particular packet from this interface or from this over this wire. It is as simple as that, right? So if you have means I would say at least download Packet Tracer from Cisco Academy as mentioned by Dhaval, because from tomorrow we are going to include, maybe there is going to be first exercise tomorrow where we are putting some switches or maybe only two routers, R1 and R2. We are connecting them through a cable. It should be crossover cable, and now you must be thinking that again you are going into the straight and cross through cable, right? Because we all know now that R1 and R2 has a feature called auto MDIX. They can arrange themselves. Doesn't matter where everybody is sending or receiving, right? So you just connect R1 and R2 with a cable here, but Cisco Packet Tracer give you the option of connecting the through straight through or through crossover. Just try different experience. Just try to connect it with different cables to see the output, right? Then you are going to say, this is my interface number 0/1, this is 0/2, assign the IP address, and then try to communicate. How to see that whether these are communicating? There is a ping command which we will be discussing in tomorrow's session. So tomorrow's session is going to be very, very interesting because we will be talking about how to computer A and B, which are pretty nearby, are going to communicate over this switch. Yes, this topic is not yet over. We have just discussed the broadcast address. Anjali is shouting, where is Mr. Rahul, right? How actually it is happening at the packet level. We are literally seeing the packets there. Tomorrow's session is going to be very, very important because we are connecting two computers which are quite close to each other. Then we will be connecting two computers which are way apart, right? We will be combining Ethernet and IP layer. You will come to see how these two layers, IP plus Ethernet, combine together with which is giving you the entire internet. So do not miss tomorrow's session. Again, that is going to be the base for you. The starting 2 hours, we are going to again going through the theory, and the last 1 hour will be the practical, right? So everybody install this packet tracer software, and we will be giving you some exercise tomorrow. Having said that, thanks for being a wonderful audience. Thanks for asking questions, although you are not asking much. but that is perfectly fine. Having said that, bye for now. Enjoy your day. See you tomorrow
Bye
at
everyone.
9:30.